All right, guys, welcome back. Today, we're going to look at an algebraic way to solve a system, and it's called the substitution method. The first method you should already know is that you can graph both of these equations on a coordinate plane and see where they intersect. And remember that their intersection point is the solution to the system because it solves both equations at the same time. So awesome. So let's get started. So the first thing you should do is we need to isolate one of the variables in one of the equations. So we have two equations here. I would look at the first one first. And that is because when I look at y, I know that y looks like it's really easy to isolate. So let me write this equation over here. We have minus 12x plus y equals 15. This would be very easy for us to isolate y. The only thing we would need to do is to add 12x to both sides. And that will leave us with the expression the equation y equals 12x plus 15. Now, this is an important first step in substitution because what we're going to do is we're going to substitute 12x plus 15 in for y because y is equal to 12x plus 15. They have the same value. They are equal to each other. So the next step in substitution would be to take this expression right here, 12x plus 15, and replace y with it in our second equation. So that means that if I we'll start to rewrite the second equation, 3x plus 2 times y, except instead of a y this time, I'm going to plug in the expression 12x plus 15. And notice this equation still equals 3, just like the second equation did. So now if we look at our equation now, we no longer have any y's, which means we can get a numerical answer for x. So let's continue to simplify. So it looks like next we'll do the distributive property. 3x plus 24x plus 30 equals 3. Let's combine some like terms here. This becomes 27x plus 30 equals 3. Subtract 30 to isolate x. And we have 27x equals negative 27. Last step, divide, almost done. And we have x equals negative 1. Sweet. Okay, so it feels like we're done, but we're not. So we got an answer of x equals negative 1, which is great, but remember, the solution to a system is a point, an ordered pair where they cross. And negative 1 is not a point. So that means that we know the x value of our coordinate where these lines cross. And so we're going to need to figure out what its y coordinate would be. Because remember, a coordinate is always x comma y. So how do we find y, you ask? Well, that's easy. You just plug in negative 1 into one of your equations. Now, but there's a trick though, because technically we already solved an equation for y. So it would be really, really easy to plug in for x in this equation. That's usually the way I recommend it, is to plug in your unknown into the equation you solved in the first step. But technically, you can plug it into any equation you want that you're given. So you can plug it into the top equation, you can plug it in over here, or you could even plug it in way over there. It doesn't really matter. It's up to you. So I like to use our rectangle equation. So let's plug that in real quick. So we would have y is equal to 12 times negative 1 plus 15, which means y equals negative 12 plus 15, and therefore y must equal 3. So that means that their point of intersection of these two linear equations is found at negative 1, positive 3. And once you do that, you are done.